Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe.
Hello, future engineers. Here is another video in calculus, particularly on the applications of derivative, particularly on evaluating derivatives using chain rule. So here we go. These problems, I think, are taken from the book by Love and Rainville. So find the first derivative. These are the 10 exercises. 11 to 20. So it will take time. I hope that you can follow my solutions presented and the explanations. So y equals square root of 2ax minus x squared. So it's like y equals square root of u. This is the whole u. And the derivative of square root of u is derivative of u with respect to x in the numerator divided by 2 square root of u. So if u is quantity 2ax minus x squared, so the derivative of u with respect to x is 2a minus 2x in the numerator. Then we copy in the denominator 2 square root of u, 2 square root of this. We just copy that. So dy dx is 2a. So in the numerator, derivative of u with respect to x, 2a minus 2x all over 2, then copy square root of 2ax minus x squared. In the numerator, 2 is common, so we can cancel out 2. So the final answer dy dx is a minus x over square root of 2ax minus x squared. So that's for number 1. For number 11. For number 12, derivative of v with respect to z is, we have power formula, 3 halves, then quantity z to the fourth minus 2z plus 1 raised to 1 half, where 1 half is 3 halves minus 1, then times the derivative of the terms inside the parentheses, which is 4z cubed minus 2. So again, dv dz is equal to 3 halves times quantity z to the fourth minus 2z plus 1 to the 1 half, then times 4z cubed minus 2. So for the expression 4z cubed minus 2, 2 is common. So we'll have 2 quantity 2z cubed minus 1, cancel out 2. So the final answer is dv dz is 3 times 2z cubed minus 1. This becomes 2z cubed minus 1 times the quantity z to the fourth minus 2z plus 1 to the 1 half. So dv dz is 3 quantity 2z cubed minus 1 times the quantity z to the fourth minus 2z plus 1 to the 1 half. Then number 13, this is derivative by product rule, derivative of product. So we have dy dx is equal to first x squared, then times derivative of second 3 quantity x plus 1 square, derivative of x plus 1 is 1. So x squared times quantity 3 times quantity x plus 1 square times 1. Then plus second x plus 1 cube, derivative of x squared is 2x. So we factor out, so x plus 1 cube times derivative of x squared, which is 2x. So common is for x plus 1, it is x plus 1 square. That's the common. And for the constants, there's no common. For x, x is common. So we factor out x times quantity 3x, x times quantity x plus 1 square. Then the first factor is 3x, so x times x plus 1 square times quantity 3x. Then here plus 2 times quantity x plus 1. So 3x plus quantity plus 2 times quantity x plus 1. Simplifying, so this is 5x plus 2, this one 5x plus 2. So dy dx is equal to x times x plus 1 squared times 5x plus 2. Number 14, f of x, x cubed, quantity x squared minus a squared to the 1/2. So we have product again. F prime of x equals x cubed, then times 1/2 times 1/2 quantity x squared minus a squared to the negative 1/2 times 2x, which is the derivative of x squared minus a squared, so times 2x. Then plus second, we copy quantity x squared minus a squared to the 1/2. Derivative of x cubed is 3x squared. So times 3x squared. So let's factor out common factors. So take note that we can cancel 2. So for x, the least common factor is x squared. We have x squared here also. Because we can cancel 2, so there's no common for constants. Then for x squared minus a squared, the least common factor is x squared minus a squared to the negative 1/2. So we have f prime of x equals x squared times quantity x squared minus a squared to the negative 1/2. Then times what is left here is x squared, and here it's 3 times quantity x squared minus a squared. So times quantity x squared, then plus 3 times quantity x squared minus a squared, because that's 1/2 and this is negative 1/2, so that makes it so that's positive 1/2. That's correct. So let's simplify this inside. This is 4x squared minus 3a squared. So final answer, f prime of x is x squared quantity x squared minus a squared to the negative 1/2 times quantity 4x squared minus 3a squared. So that's it for number 14. For number 15, this is derivative of product again. F prime of v is equal to first v times derivative of second, which is negative 1/2 quantity v squared plus b squared raised to negative 3/2 times 2v, the derivative of v squared plus b squared, so times 2v. Then plus second, we simply copy this. Derivative of v is 1 with respect to v. So plus quantity v squared plus b squared raised to negative 1/2 times 1. So we can cancel out 2. For the expression quantity v squared plus b squared, the least common factor is this one, quantity v squared plus b squared raised to negative 3/2. And since we cancel out 2, so we have times the quantity negative v squared. Then in the second, we have quantity v squared plus b squared to the 1. So that's it. So f prime of v equals, we have quantity v squared plus b squared raised to negative 3/2, then times open quantity negative v squared, then plus quantity v squared plus b squared to the 1. So simplifying this is just b square. So the final answer f prime of v is we have quantity b square, this is b square, then times quantity v square plus b square raised to negative 3 halves. Let's proceed to number 16. This is derivative of product again. So y prime is equal to first x, derivative of seconds is 3 halves quantity a square minus x squared to the 1 half times negative 2x. Derivative of a square minus x squared is negative 2x. And plus second, we simply copy this. Derivative of x is 1, of course, with respect to x. So plus quantity a square minus x squared raised to 3 halves times 1. So 1 is not shown here. So the common, we cancel 2. The common factor is this a squared minus x squared to the 1 half. So times 1, that's it. So y prime is quantity a squared minus x squared raised to 1 half. Then we have times open quantity negative 3x squared, because after we cancel out 2, negative 3x squared, then plus quantity a squared minus x squared to the 1. So simplifying, y prime is quantity a squared minus x squared to the 1 half. Then this is a squared minus 4x squared. So a squared minus x squared quantity raised to 1 half times quantity a squared minus 4x squared. Number 17, this is again derivative of product. So y prime is first x to the negative 1 times open quantity 1 half quantity a squared plus x squared to the negative 1 half times 2x, because derivative of a squared plus x squared is 2x. Then plus second, which is this, copy. Then derivative of x to the negative 1 is negative 1x to the negative 2. So cancel out 2. X to the negative 1 times x is x to the 0, or simply 1. So what remains here is a squared plus x squared to the negative 1 half, which is the common factor. So y prime is quantity a squared plus x squared to the negative 1 half times open quantity 1, because what remains here is 1, times this. Then in the second, this is minus quantity a squared plus x squared to the 1, then all over x squared, all over positive x squared. So 1 minus open quantity a squared plus x squared to the 1 over x squared, where x squared in the denominator is this x to the negative 2. Then that negative 1 is this negative sign here. So simplifying, the terms in these brackets is x squared minus a squared minus x squared. So we cancel out x squared. So what remains here is negative a squared. So the final answer, therefore, for number 17 is x to the negative 2, then times quantity a squared plus x squared to the negative 1 half. So y prime is, we can write this as a squared plus x squared to the negative 1 half times, this is 1 over x squared, negative a squared rather over x squared, or negative a squared over x squared, or negative a squared x to the negative 2. So the final answer is y prime equals negative a squared x to the negative 2, because we write the answer in the same form as this. Then copy quantity a squared plus x squared to the negative 1 half. Number 18, So this function, I just call it chi, which is 3, rewritten as 3 quantity 16 plus t to the fourth raised to negative 1/2, so that we can easily evaluate the derivative. So this is 3 times negative 1/2. Psi prime is negative 3 over 2. Quantity 16 plus t to the fourth to the negative 3/2 times 4t cubed. Derivative of 16 plus t to the fourth is 4t cubed. So negative 3 times 4 over 2 is negative 6. So the final answer is negative 6 t to cube over quantity 16 plus t to the fourth raised to 3/2, because we want the answer to be of this form also. Although the answer may also be negative 16 t cubed times quantity 16 plus t to the fourth close raised to negative 3/2. So that's also acceptable. Number 19, this is derivative of ratio. So y prime is denominator x times derivative of numerator, which is 2 quantity 1 minus 2x to the 1 times negative 2, which is that. So 2 quantity 1 minus 2x to the 1 times negative 2. Then minus numerator, so we copy the numerator. Derivative of denominator is just 1. Then all over denominator square, which is x square. Simplifying the numerator for 1 minus 2x, the common factor is 1 minus 2x. Then we'll have negative 4x, then minus 1 minus 2x, quantity 1 minus 2x. So y prime is quantity 1 minus 2x times negative 4x, then minus quantity 1 minus 2x, all over x squared. So the final answer, simplifying this terms inside this bracket, so negative 4x plus 2x is negative 2x minus 1. This is negative 2x minus 1. So y prime is quantity 1 minus 2x times negative 2x minus 1, or negative of quantity 1 plus 2x, all over x squared. So since this is 1 minus 4x squared, negative of quantity 1 minus 4x squared, the numerator, negative of quantity 1 minus 4x squared over x squared. So if we distribute the x squared, the final answer is negative of negative 4x squared over x squared is 4. And the first term is negative 1 over x squared, or negative x to the negative 2. So the final answer may be written as negative x to the negative 2 plus 4. So that's it for that problem. Then let's problem 20. This is the last part. So y is quantity x plus 1 cube over x squared. So we have derivative of ratio. So denominator y prime is denominator x squared times derivative of numerator, which is 3 quantity x plus 1 square times 1. Derivative of x plus 1 is 1. Then minus numerator, we copy numerator, derivative of denominator 2x. Then all over denominator square, which is x to the fourth. So minus quantity x plus 1 cube times 2x all over x to the fourth. Common in the numerator is x plus 1 square and x. So we have y prime is x times quantity x plus 1 square, then open quantity 3x, then minus 2 quantity x plus 1. So x, quantity x plus 1 square, quantity 3x minus 2, quantity x plus 1, all over x to the fourth. So take note that we can cancel x, so the denominator becomes x cubed. So it is now free of x here. These terms inside these brackets is, when simplified, is x minus 2. So y prime, one possible answer is y prime equals quantity x plus 1 square times quantity x minus 2 over x cubed. So that's one answer. The other possible answer is if we distribute, this is x squared plus 2x plus 1, then times x minus 2 over x cubed. So we have x cubed minus 2x squared, then plus 2x squared minus 4x plus x minus 2 in the numerator over x cubed. So we can cancel 2x cubed, then this is negative 3x minus 2. So y prime is x cubed minus 3x minus 2 all over x cubed. This may also be the other possible answer. Or if we distribute x cubed in the denominator, the other possible answer would be y prime equals 1 minus 3x to the negative 2 minus 2x to the negative 3. So y prime is also 1 minus 3x to the negative 2 minus 2x to the negative 3. This may also be the answer. That may also be the answer. So that's it for this video.